Here we will start by, let's try to simplify f theta. We are given this is half times mod or det sine theta Okay, so to simplify this, we will do C1 goes to C1 plus C2. So notice that the second and third row entries of the first column will become 0 after this operation. So that gives us this determinant. So this determinant will then become half by doing the operation C1 goes to C1 plus C3. So this half goes inside and we'll multiply this by the first column. So this will become 1. So now we'll open simply this into this minus this into this. The determinant value of this becomes 1 plus sine square theta. And the second determinant, sine pi is 0. If this is A, this is B, then notice that this is minus A and minus B respectively. And notice the remaining two diagonal entries are 0. And if this is minus C, this is C. In other words, the second determinant here is an skew symmetric. The second matrix has a skew symmetric matrix, so its determinant should be 0. Where A is cos theta plus pi by 4, B is tan by 4, and C is ln. Because tan theta minus pi by 4 is same as cot pi by 2 minus pi by 4 minus theta, so that becomes cot, and that is cot pi plus c pi by 2, which is cot becomes cot pi minus, which becomes minus cot theta plus pi by 4. So yeah, verify yourself if you have any doubts that this second matrix is a skew symmetric matrix and hence the determinant is 0. So that simply leaves us with the fact that f theta is 1 plus sine square theta. That makes g theta mod sine theta plus mod cos theta. So maximum will be root 2 and minimum will be 1. If you have a doubt with this, what we'll do is g square theta equals to 1 plus mod sine 2 theta so max of g square theta would be 2, min would be 1, which means max and minimum of g theta respectively are root 2 and 1. So I squared this to find the max and min value of this term g theta. So yeah, so now that we have the max and min value of g theta, we can say our polynomial p x is k times x minus 1 into x minus root 2, because 1 and root 2 are the roots of this polynomial, and we are given p2 is 2 minus root 2. So k into 2 minus root 2 which gives us k equals to 1, which in turn gives us px so this function px would be less than 0 when x is in, but 3 plus root 2 by 4, yeah, it is in x, because it's in this interval because it is 3 by 4 times 1, 2 by 4. So this point in option A this point is in this interval, so it would be less than 0. So A is correct, B is incorrect because 1 plus 3 root 2 by 4 is greater than 1 and less than root 2. The point 5 root 2 by minus 1 by 4 is root 50, which is root 50, or in fact it divides the line segment 1 to root 2 externally in the ratio of 5:4. So option C is also correct. And 5 minus root 2 is less than 1, because 5 minus root 2 is less than 4 as root 2 is greater than 1. So D option is wrong, because we have that px would be less than 0 if and only if x is less than 1, like x is greater than 1 and less than root 2. So the final answer is A comma C, because 5 minus root 2 by 4 is less than 1. So yeah.